welcome back for more 4 Caillou action. This one's called the Observed Pin. Your instructions. Basically, you're like a detective. You've got some intel on a robber. He's storing all of his stolen goods with this simple keypad structure here. You need to basically crack the code and figure out the pin. It goes like this. You have some intel where someone is giving you the pin numbers that they think they saw entered, and the catch is that they may not be precisely right, meaning for each character your intel reports to you, it could be off by one value. And by that I mean it can be a neighboring value either to the side, above, side, or below, but not diagonally. So for example, if they reported one of the digits was a 1, that means it could have actually been a 1, or it could have been a 2 or a 4. If someone reported a 5, it could have been 2, 4, 5, 6, or 8, etc. And so you have to basically generate a list of all these permutations of possible answers with the idea that you could run that through the keypad to find the one that actually works. Feel free to read the description. I try not to do that because I know you know how to read. They used an example pin here, 1357, and as I describe my algorithm, I'm going to use that pin value as well, just to give us something concrete to look at. Anything else in here? You could have 1 to 8 digits in the pin. Note that they pass it in as a string because you could have leading zeros in it. And I think that's all you really need to know. Yeah. So go ahead and finish reading this if you'd like. I'm going to start formatting and give you a chance to pause the video and try this one out for yourself, and then come on back when you're ready. Okay, good. We've got a good starting point. Now, I wrote out ahead of time some notes to describe the algorithm I'm going to use to solve this, and I'm going to use this concept of what I'll call key pools. And so I want this, I'm going to make a helper method where no matter what number I pass to it, representing a key here, it'll give me a list of all the potential values that it could have been. So back to that, you know, if I pass in 1 to the method, it'll give me 1, 2, 4. That's that sort of thing. And so here, I'll write some comments above here. Paste these in. I have these key pools, so we're using 1357, the example offered. And so it would basically return a list of 1, 2, 4 for 1, 2, 3, 6 for 3, 2, 4, 6, 8 for 5, and 4, 7, 8 for 7. Go ahead and convince yourself that those values are accurate. And then the idea being is that after I generate these key pools for whatever pin numbers passed in, it doesn't have to be 1357, but we're just using that. I'm going to make a separate collection that I'll call indices, right? And it's size 4 here because we're dealing with 1357. But if it's size 8, imagine 8 of these values. And the idea being that I start at all zeros, right? And so I just take the key pool values associated with these indices. So it would be 1, 2, 2, 4, right? Index 0, meaning take the first element in the list. And that's why I have the arrow going to 1, 2, 2, 4. And then I'm going to have a method that will sort of maintain this collection, and it can increment it for us. And so what does that mean? Well, bump the first index 1, and you see when you do that and grab the corresponding values from the key pools, you get a new code. You get 2, 2, 2, 4, as I've shown here. And so feel free to pause the video and see how this would, try to imagine how it would work. You get to 2 because there's 3 indices here, but that's the max, right? I can't go 3 because I'd overrun the bounds. So notice how after that third one, it gets reset back to 0, and I bump the next index, and I repeat the whole process like that. I'm sorry, I see now it wouldn't increment like this. It would be, let's fix this, 1, 1, 1, 0. So that would be 2, 3, and then 0, 0, 2, 4, something like that. And then you'd get 2, 1, 0, 0. And that should go to 4, 3, 2, 4, right? Something like this. And then it's going to roll over again, right? It'll go 0. Then you bump that one up 0, 0. And that should go to, would be the pin for this. You'd have 1, 6, 2, 4. And then you see how, 0, 1, 2, 0, 1, 2, 0, 1, 2. Then these ones 0, 1, 2. They all get bumped, and hopefully you can see this pattern emerging that eventually all of these cycle through all their possible values, and I'm pulling pins each time, and finally it ends when each index is sort of at its max value. Remember, this is specific to this 1, 3, 5, 7 example, but index 4 would be the max for a size 5 list, right? So I hope that's clear. This is the thing that I'm going to implement. If you were stuck and had seen this, you could feel free to pause this again and see if you can implement what I've written here on your own. Otherwise, let's get started. So I'm going to have this idea of indices, right? So let's set that up. Let's say a list of int, I'll call it indices, equals, now I want mine to be filled with zeros by default, so I'm going to use our friend enumerable repeat, and I'll say 0. And how many of them do I want? Well, it's the length of the string, right? That's how many characters are in the pin number. And then remember, repeat returns an IEnumerable of int, but we know we have this handy toList method, which can get us back to the list type that we're looking for. Now, for these key pools, I'm actually going to make this as a list of lists. So this would be, the first list in it, this would be the second list in it, the third, etc. Let's set something like that up too. We can go list of int, key pools equals new list of int. It's a little bit of a mouthful, isn't it? And then one thing, if you didn't know, you can set the capacity of your list like this up front. Note that this won't actually put the elements in, it's just reserving the space. So it's setting the size so it doesn't have to reallocate space as you add elements to it. It's not required, you don't have to do this, but it's something that's good to know, and this is educational. Go to the list constructor documentation if you want to see that overload for more information about that. So it's just saying, okay, we have our key pools. They're going to be, the number of them is going to be equal to the length of the pin we get passed in. That's what I was trying to say there. At least it has the capacity for now. And let's set up a final list, because this method requires a list of strings as output. And I'll initialize that so we can start adding values to it. Okay, so these are the data structures I'm going to use for this. Now, first thing, let me go ahead and add the lists to key pools. So I would do something like int I equals 0, I is less than observed dot length plus plus I. Nothing amazing there, right? Standard for loop. And the idea being is, okay, let me get the value from the current character, right? So I can do, we've seen something like this before where I can go observed I, right? When I is 0, that's just going to take the first pin character. And what I'm going to do is subtract it from 0, because I know in the ASCII table, right, these number characters appear consecutively. So consider this as the character 1. If I subtract 0, the character 0 from it, it's going to be distance 1 away, and that's how it turns into an integer value. That's how I'm pulling the integer value from this. Hit me up with questions if that's not clear, but I think that should suffice. And then the idea being is once we have that, wouldn't it be nice if we had a helper method that could just get us the possible key values that are associated with that value? So let's make a helper method to do that. Private static list of int is what we're looking for. and we'll call it get possible keys. Get possible keys. And for this, we need to tell it what number it was that we want the values for, right? And so for get possible keys, I'll go ahead, and this is one I also typed out in advance, so you didn't have to watch me type out 9 different cases or 10 different cases. So I'll copy that in here for us. Save a little time. I don't think you lose anything by me not typing all this out in front of you. So yeah, typical switch statement here. And then you can see, go ahead if you like, pause the video and make sure I got these values right, or that you understand why I put for key 1 the values 1, 2, and 4. Note I include the value itself in there. So yeah, that's a nice little helper, right? Now when we have this for our key pools, oops, we can say key pools add get possible keys val. And again, if you don't want this temporary val variable, just copy this bit in as your argument. That works well too. So at this point, this is nice. All of our key pools are generated. So we've got something like what I depicted up here on the right side of the arrows. We've got some collection that has all these lists in it based on whatever input was passed to us. So that's a great start. Okay, so next, let's go ahead and we're going to add the default value, because indices we already initialized to say 4 zeros. So there's a pin that can be that's associated with those indices, and let's go ahead and add that right to our result. So result add. Now let's go ahead and make another private method to handle a little bit of functionality, and it's going to go like this: get next pin. And what it does is takes the current indices, the current key pools, and it pulls those values from the key pools based on whatever your current indices are. In our case, they'll be all zeros to start. So for get next pin, we're going to have to pass in list of int indices and list of int key pools. Now this method was static, and that's why I'm doing this all statically. If I had done it on my own, I'd probably make these indices and key pools as member variables, and then I wouldn't have to pass them in my functions here in my class. But since this is all static, I'm passing them as parameters in here. That's why I chose to do that, in case you were wondering. So this can be pretty simple. We can say string pin, just initialize it to nothing. And then we can go through the length of it again. We can simple for loop, int I equals 0, I is less than indices dot length is what we have to work with. And since indices is a list, it should actually be count. Isn't that awful how the different collections have a different property name? Yuck. And then finally return the pin once we do our work. But this will be a handy little tool to do that. And so, like I said, pin plus equals, we're going to do it one character at a time. And the first thing you have to do is get the associated key pool, the first one if you're on index 0. And then once you have that, you're going to access within that list the current index value, right? So you'd say indices I. And if you want to put print statements in here, console write line, go ahead if you want to see this running in action. But really it's as simple as that. We're generating a pin value based on the current indices, all zeros to start. And so since it is initialized that way, I can start by saying result get next pin indices key pools. And that sort of gets us off and running with that first value. Now the second part of this is is that we need to increment the indices in the way that I described earlier. And so I'm going to make a separate method to do that. But you can imagine once I have that, we can do something like this. While increment indices, and we'll have some arguments in there. And you could say the same kind of thing, right? Result add, it's going to be get next pin, and it'll be the same thing, indices and key pools. In fact, I don't even need the braces there since it's one line. And then finally we'll return the result, but we got to make this happen. Notice how I'm making this return a Boolean. So I'm using that in a way where I'm going to have the method return false when we sort of max out all the index values. In the example above, that was when they all were at 2, 2, 4, 2. But it'll be specific to whatever the input we get is. So let's go ahead and make that increment indices. Private static, we know it returns a bool. I'm using it as a condition for my while loop. Increment indices. And then for the indices, I'm actually going to pass the indices by reference, and that way I can modify it within my method and those changes will persist. We know that by default, when things get passed by value, when you modify them inside your method, those changes are kind of discarded. It happens on the call stack, it's not persisted. And in this case, I want it to persist. That's why I use the ref keyword for this parameter, in case you were wondering. And then we'll also need the key pools. List of int key pools. Okay, so we have our scope for increment indices. Now, let's loop over the indices and start incrementing them, right? And we have to handle the situation where there's rollover. When we go beyond the bounds of an array, we have to reset the index to 0 and sort of bump the next index in the collection up 1 and kind of repeat that process till the whole thing's maxed out. That's in that way we get everything. So let's make a for loop for that too. For int I equals 0, I is less than indices dot count again. Man, I probably typed one of those wrong. We'll see. Okay, good. So we're going to go through all the indices. First things first, we already called, yeah, we got this once with all zeros. So the idea is that you bump the first value. Every time you say increment, that's what we mean when we say increment, right? Let's bump the first value. And then we have to handle the case where there's potentially overflow. If there is no overflow, fine, just return and be done with it. But we could have a case where indices I is greater than or equal to key pools I dot count, right? Then this is a problem, right? It means, okay, you know, if the last index was supposed to be 2, now we're up to 3, and that won't work. If we try to use 3, we're going to crash. So we don't want to do that. Let's fix that. We can say indices I equals 0 in that case. And then the idea being that if there was no overflow, just return and be done with it, right? Or I suppose we return a Boolean, so I'll say return true because we're not at the end of the incrementing yet, right? If you haven't overflowed, you're not at the end. And then we have to return something, in this case too, outside the loop, or we're going to get yelled at. So now all paths return a value. And then the part where I make this stop when everything's maxed out. So imagine the last index went over. That's when I know I'm maxed out. And so how do I express that in code? Well, if I is equal to key pools count minus 1, that would be the last index, right? Then we'll say return false. You maxed out the last index, so we're done. Remember, when it finally gets this false call, it's going to stop that while loop. And so that should be enough to do the incrementing, right? First time through, it's going to bump 0 to 1. It'll just exit right away. 1 will go to 2. 1 will go, I'm sorry, 2 will go to 3. We'll hit this clause, or we hit the count, and like, uh-oh, set it back to 0. Since it's not the last index, you'll get another iteration of the loop. You'll come through, and I will now be 1. You'll bump that. And if what I'm saying, again, put those print statements in if what I'm saying isn't clear, and you can watch these values changing as the program runs. But something like this should get us there. So let's see here, what do we have? We've got our data structures. We load up the key pools. We started, since indices is all zeros, we don't want to miss that because increment's going to bump them. So make sure you get the result associated with the default all zeroed indices. And then finally, just keep cooking here. Bump them up by 1 at a time. Go through every possible permutation. Eventually this thing will hit false. You'll fall out of the while loop. After, you should have added to result every possible pin involved. So I'm going to try running this. Let's see what kind of stupid typo I made. Enumerable does not exist. That's fair. We didn't put in using system link, right? Let's try again. There's no argument that corresponds to the required formal parameter indices on line 37. What do we do there? Oh, sure. So, yeah, let's use ref since we're passing indices by ref, and then key pools. Yeah, you definitely need arguments. That's how we define this method, right? That's fair. The name keypoola. Oh, a little too eager there. That's also a fair complaint. The namespace you are looking for, arguments exception could not be found. So yeah, remember in that part I pasted in argument exception. You can look that up if you'd like, but it should be in the system namespace. Maybe you already had that in if you were using console write line. Okay, good. We hit green. I'll hit the attempt. It's thinking. Come on, green. There we go. We nailed it. So yeah, I don't have any print statements to show here. We can take a quick overview. I'll put in algorithm. Maybe I'll leave this in my submission. Maybe it'll help somebody else think about the problem. And that's going to mess with my LCD. So yeah, let's see here. I don't think I have anything I need to remove. I mean, this can't, come on, this is for Caillou. I don't need to write stuff out like that. On one lines, I don't like curly braces, just personal preference, doesn't hurt anything. So yeah, not bad, right? We did this pretty cleanly, I'd say, and I like the way this came out, where you look at each of these helper methods, they're each doing a very small focused job that's, I think, clear and easy to understand. So yeah, I'll run mine again, and I'm probably going to submit mine off like this. I think I did enough explaining of the algorithm, but you know where to find me if not. Let's go back, hit that attempt, give us some more green. There we go. I'm going to fire mine off and collect those points. I would be very interested in what solutions you came up with as we get into these higher Caillou levels. There's a lot more possibilities and opportunities to do really neat and cool things. So it's even more important to go through these other solutions. Like, look at some power link there. Really nice. So I'm going to do the same and go through these Otherwise, yeah, hit me up with questions, comments, concerns. Otherwise, I'll see you in another video. Thanks for watching.